Today we're starting section 7.2. That's why it says we're just on day 1. We are going to multiply and simplify radical expressions. It's not going to be a whole lot different from what we were doing on Friday or what you just saw on that hand-in. Alright, so on this first part, it's sort of like a mini warm-up here. We're asked to notice the following. If we take the square root of 16, what do we get?
4.
And the square root of 9?
3.
Now if we multiply them together. Okay? Alternatively, we could multiply the 16 and the 9 together right away. So that's why they put them under the radical together. So 16 times 9 gives us 144, and the square root of 144? 12. So notice that we get the same answer either way we do this. So here is that property written out. The property of multiplying radical expressions. If the nth root of A and the nth root of B are real numbers, then the nth root of A times the nth root of B is equal to the nth root of A times B. So this is what goes in that big old box. All right, so these are our first set of examples. As you're copying them down, you will notice that on all of them, you are taking the same type of root each time. So on the first one, both of them are square roots. On the second one, both of them are cube roots, and so on. In order for this property to work, you have to be taking the same root on both of them. I believe later in chapter 7, we'll talk about how to deal with different roots getting multiplied together. But for now, they just need to match. So on the first one, in order to multiply it, we're going to multiply 2 times 8 and it will stay under the radical. You do not have to write the part where they're together under the radical if you don't want to, but that illustrates the property. 2 times 8 is 16. The square root of 16 is 4. If you're still putting plus or minus 4, that's fine. But remember on Friday we talked about when we take a square root or any even numbered root, generally we just care about the principal root or the positive root. On number 2, we are taking the cube root of negative 5 times 25. What is negative 5 times 25? Good, negative 125. And the cube root of negative 125 is negative 5. Number 3, we're back to taking square roots. The square root of 3 times 12. What is 3 times 12? The square root of 36 is 6. On number 4, the cube root of... Good. 3 times negative 9 becomes negative 27. The cube root of negative 27 is negative 3. Remember, we can take odd roots of negative numbers without a problem. On the last one, we are back to a square root of negative 2 times 8. Negative 2 times 8 is?
Negative 16.
Negative 16.
No.
The square root of negative 16.
Negative 4.
Lower root.
Lower root, sorry.
So let's pay attention to our directions. Do the directions on your page match the slide? Multiply, simplify if possible. Okay, so does it say anything about it having to be a real root? No, it doesn't say it has to be real. So if it doesn't specify that it should be real, we have learned how to deal with a negative under a square root.
Oh, negative 4i.
4i.
Just 4i, good. Okay, now on your tests and quizzes and so on, I'll try to be specific, or you can always ask me to clarify for you. Okay, but if the directions don't say that it has to be a real root or find the real root, the directions don't say the word real anywhere in it, then we technically are fine to put I in our answer. For this next part, we are given a little helpful hint. To break apart radicals to simplify, assume that all variables are positive. So let's work through number 6 first. I sort of mentioned this a little bit last week, that it helps if you think about the square root of 72 separately from the square root of x cubed. Okay, so now we're taking that property and working it backwards. So instead of putting them together, we're splitting them up. So let's think about each of these separately. If I'm taking the square root of 72, is that a perfect square number?
No.
No. So I have to make a little tree. What can 72 break into? 8 and 9. 8 breaks into 4 and 2. 4 breaks into 2 and 2. 9 breaks into. Okay. If we're taking a square root, we're looking for groups of 2. I have a group of 2 3s, and I have a group of 2 2s. And what's alone?
2.
A 2. Okay, so just for the square root of 72, what would that simplify to be? Okay, the 2 and the 3 get multiplied together. Outside, so 6 root 2, the 2 stays inside. But we're not done, so I would maybe extend your, well, I would either leave a little space between the 6 and the radical and extend your radical out a little bit, because we still need to deal with the x cubed that's getting square rooted also. Otherwise, you'll just have to write a couple steps. If we are square rooting x cubed, last week we talked about dividing the exponent by the index. Will this divide evenly? No. So let's think about this. This is the square root of x times x times x. That's what x cubed means. We're taking a square root, so we're looking for groups of 2. So I have one group of 2, and then I have how many that are alone? 1. So when I go to write the rest of my answer, what's going to come outside the radical? One of the x's from that pair, and what stays inside? The one that was alone. So we formed our answer, doing it one part at a time. Deal with numbers separate from variables. All right, let's try number 7 together as well. Again, this time we're taking a cube root. So the cube root of 80 times the cube root of n to the 5th. This time I'm going to do my work off to the side, just so I have a little more space. If I'm taking the cube root of 80, I need to break it up. What can 80 break into? 8 times 10. 8 breaks into 4 times 2. 4 breaks to 2 and 2. The 10 breaks to 5 and 2. This time I'm taking a cube root, so I'm looking for groups of 3. What do I have a group of 3 of?
2.
2s. Got a group of 3 2s. What's alone?
5.
The 5 and another 2. So the cube root of 80 simplifies to be what?
2. Oh, what?
What's going to come out?
Oh, 2.
A 2 from this group. So a 2 comes out. I'm going to leave a little bit of space.
5. 2.
And the cube root of 10. Good. Remember, anything that's alone gets multiplied back together if it has to stay under the radical. Now we have to deal with the cube root of n to the 5th. So n to the 5th we could rewrite as how many n's? 5 of them. We're looking for groups of 3. So I've got 3 here, and then what's alone?
N.
Okay, both of those are alone, so they both have to stay inside. So what's going to come outside by my 2? An n from that group. And what's going to stay inside?
N squared.
N squared, because there were 2 left over. Now you might remember me saying last week when we do the division, whatever your remainder is, that's what stays in. Right? So if we were to take 5 divided by 3, that would be 1 with a remainder of 2. 1 on the outside, 2 on the inside. Does that make sense? If not, you can still write it out and find your groups. That's always a way that's going to work. But if you can get used to the division rule, it might help it go a little quicker. Can anyone volunteer to tell me what they got for number 8? Emily?
2 and
What?
cube.
I think you might be on a number...
Oh, sorry, you meant 9.
Yeah, so number 8, what do you have?
Oh, number 8, right?
I think, are yours labeled differently than mine? So the very first one on the back side. Sadia, do you got that one?
Yes, 5x square root 2x.
5x,
Square root 2x.
like that?
Yes.
Are you sure?
Let me take it.
Jacob, help us out just a little bit.
5x squared square root x.
Well, if you put your answers together, I think I would agree.
Oh, 2x.
Yeah, so we do want a 2x inside, but we would have an x squared outside. So for the 50, we would break it into, most people would probably break it into 25 and 2. 25 breaks into a pair of 5s. That's how we end up with a 5 outside. The 2 doesn't have a pair, it stays in. X to the 5th, if we're simplifying that part, x to the 5th is 5 x's multiplied together. We're looking for groups of 2 because it's a square root. So there's a pair and there's a pair. The one on the end is alone. So for each pair, you can bring one out. So there were 2 pairs, that's how I got x squared. 1 alone, that's the plain old x. So that is how we build our answer. We just do it a little piece at a time. Does anyone have an answer for 9 they would like to share? Emily?
3n squared. Oh, no, sorry. No. Yeah, 3n squared. Square root of 2n squared.
Cube root of 2n squared? Both the n's are squared?
Yeah.
Do we agree with this?
Yeah.
3n squared, cube root, 2n squared. Make sure when you write your answer that you keep whatever root that they have. So if they started with a square root, your answer has a square root. If they started with a cube root, you make sure to put your index of 3 to show you have a cube root. Does anybody need to see 54 or n to the 8th broken down to how we got that? Are we okay? I'm going to assume we're okay if you don't tell me otherwise. All right, anybody new have an answer to share for 10? No, I should just pick on people. All right, Jacob, you can help us one more time.
2y square root. I meant 4
Mm-hmm.
2x to the third y to the
Y to the what?
4th.
Okay. All right, I would agree. 2y times the fourth root of 2x cubed y cubed. So a few people asked, I'm glad that you saw it, there are not enough x's to make a group of 4. So that means they all have to stay inside. Okay, with the y's we were able to make one group of 4 and then we still had 3 left over. That's how we still have a y cubed inside. Questions about number 10? All right, what about 11? Anybody get an answer? No brave souls. Let's just talk through number 11 then. If we are taking the fourth root of 81, 81 breaks into 9 and 9. The 9s both break into 3s. So I need a group of 4 numbers that are all the same. I've got a big group of 3s. Do I have anything left over? No. So what that means is that we'll have a 3 outside the radical. And then when we have our fourth root, we don't have a coefficient number inside anymore, which is fine. Okay, so then we have to break up the x's. How many groups of 4 are we going to find with 9 x's? 2. So that's going to be an x squared. How many would be left over? 1. So the 1 left over is inside. If we have 5 y's, how many groups of 4 will we find? 1 group of 4. So 1 outside, and how many left over? 1. So 1 on the inside. And that would be our answer. Shorten up that radical a little. 3x squared y times the fourth root of xy. On number 12, we're taking a cube root. So we are breaking down 24. What does 24 break into? 8 and 3. 8 breaks into 2 and 4. 4 breaks into 2 and 2. We're looking for groups of 3. What do we have a group of 3 of? 2's, and what's alone? The 3. So we can start building our answer. We know we'll have what on the outside?
2.
A 2 on the outside, and what on the inside? 3. A 3. It's a cube root. Okay. That is not going to be enough space, so I'm going to have to move it down a little bit here. I'll start writing it down here instead. So we have that 2 on the outside, cube root, a 3 on the inside. Okay. Then we move on to our x squared. An x squared is going to be how many x's? 2 of them. Is that enough to make a group of 3? No. So where's it going? Staying inside. It's behind the 3 inside. Y to the 5th is how many y's?
1.
5 of them. We're looking for groups of 3. How many groups of 3 would we find? 1 of them. So 1 y comes out. How many are left over? 2 of them are left over. So y squared stays in. If you still need to write them out, like write out 5 y's, circle 3 of them, that's fine. Do that. All right, z to the 9th means we have how many z's? 9 of them total. We're looking for groups of 3. How many groups of 3 are in 9? 3. So z cubed. Anything left over? No. So we don't have any z's inside the radical anymore. So that is our answer. Just build it one step at a time. Number 13. This one starts off a little bit easier. What kind of root are we taking?
Square.
A square root. So remember our index in that case is our index, a little number that sits out here, is a 2. We just don't usually see it. So if you need to write it out there, do that. The square root of 36 is 6. So when we start building our answer, will we have a number under the radical? No, because it's a perfect square number, just a 6 outside. X to the 8th makes how many groups of 2? 4 groups of 2. Anything left over? No. Okay, so we won't have any x's under that radical. Y to the 15th makes how many groups of 2? 7. So y to the 7th on the outside. How many are left over? 1. So 1y inside. Z cubed makes how many groups of 2? 1. So 1z outside. How many left over? 1. So 1z inside. Questions about how we built the answer for number 13? All right, on number 14, last one. Let's break down 54. 9 and 6. 9 breaks into 3 and 3. 6 breaks into 3 and 2. We're looking for groups of 3 because we've got a cube root. What do we have a group of 3 of? 3's. And what's alone? 2. So when I start to build my answer, what number is outside the radical?
3.
And what number is inside?
2.
Okay. I still have people that flip those around. Whatever you had a group of, that's the number that's coming out. If it has a group, it can come out. If it has no friends, it stays inside. All right, A to the 5th. How many groups of 3 will we find? 1 group of 3, and how many left over?
2.
How many? 2. Okay, so a group of 3 and then 4, 5. 3, 4, 5. All right, for B to the 6th, how many groups of 3?
2.
2 groups of 3. How many left over?
None.
Okay, so a B squared outside. It's 2 groups of 3. None left over. For C squared, how many groups of 3? None. So no C can come out. They both have to stay inside. So build your answer one piece at a time. If you need to write it out and circle your groups, do that. Our homework should be on Google Classroom. It is on page 371, numbers 1 through 22, all of them.
Whoa.